The graph shows the variation of kinetic energy with momentum squared. What are the fundamental SI units for the gradient of the graph? Alright, so the gradient here is the slope, which is the rise over the run. So in this case, we're going to have the change in kinetic energy over the change in momentum squared. And since we're looking at units, well, kinetic energy is going to be joules. But how can we really find that out? Well, we can use the formula for kinetic energy. Kinetic energy is equal to 1/2 mv squared. So if we're looking at units, we can ignore the constants and then substitute the units in for each variable. So for mass, we have kilograms, and for velocity, it's meters per second. But we still have to include the squared. So what this ends up being for units is kilograms times meter squared times s to the -2. So let me move that up here. So now we need to look at momentum. Momentum is equal to mv, mass times velocity. Momentum squared is mass times velocity, all squared. So let's do the same thing from earlier. Mass is kilograms, velocity is meters per second, and that is all squared. So what this ends up being is kilogram squared times meter squared times s to the -2. So let's move this up as well. So this is our gradient in terms of units, but that's not any of our answer choices. So let's simplify it. The s to the -2's are going to cancel, the m squares are going to cancel, and then one of the kilograms is going to cancel. So we're left with 1 over a kilogram. That is kilogram to the -1. That is answer choice A.